Hello, good afternoon. I'm discussing about qualitative and quantitative analysis. Solubility product. Solubility product is equal to the product of molar concentration of ions in its saturated solutions and denoted by Ksp. Let sparingly soluble salts, for example, silver chloride. Applying the law of chemical equilibrium, K equal to G plus Cl minus over silver chloride. Since the concentration of the undissociated solid silver chloride remains almost constant, so KAgCl aqueous equal to Ksp to Ag plus aqueous chloride aqueous Ksp equal to Ag plus aqueous Cl minus aqueous. In general, for any electrolyte X By equal to Ay plus Ybx minus Ksp equal to Ay plus X Bx minus Y, where X and Y are stoichiometric coefficients of the electrolyte. Role of the solubility product in quantitative analysis. Knowing the solubility product, it is possible to predict whether precipitation will occur or not. Let ionic product Q solubility product equal to Ksp. If ionic product is lower than solubility product, the solution is unsaturated and more solute can be dissolved in a solution. If ionic product is equal to solubility product, then the solution is saturated and no precipitation takes place. If the ionic product is greater than solubility product, precipitation takes place. This principle is called solubility product principle and valuable guide in group separation of metal ions in qualitative salt analysis. Common ion effect, the suppression of weak electrolyte by addition of strong electrolyte in which one of its ion is common is called common ion effect. Let ionization of weak electrolyte, sodium ammonium hydroxide, ammonium plus hydroxide ion, Kv equal to NH4 plus is minus aqueous NH4 waste when a small amount of strong electrolyte ammonium chloride is added to ammonium hydroxide solution, then concentration of NH4 plus ion increases, the equilibrium will be disturbed. So that to maintain the value of Kv constant, the increase says concentration of NH4 plus is consumed, that is undissociated ammonium hydroxide is formed and dissociation of ammonium hydroxide is decreased or suppressed. Application of common ion effect. Common ion effect is mostly applied in salt analysis, that is the qualitative analysis of basic radicals in group separation. When a strong analyte having the common ion is added to a solution, dissociation of weak electrolyte is suppressed to a desired extent. Consequently, conditions are created when one cation is selectively precipitated but other remains dissolved in solution. Precipitation of group first metal ions basic radicals, group first metal ions basic radicals, mercury, silver, lead. For example, silver ions is treated with hydrochloric acid, silver chloride, and hydrochloric acid as a reagent and precipitate as the chloride. Solid product of the chloride is very low in comparison of chlorides of basic radicals of other groups. These low solubility products are easily exceeded by their ionic products, hence metal ions easily precipitate on the addition of dilute hydrochloric acid. Precipitation of group second metal ions, mercury second, copper second, stannum second, cadmium second, arsenic second, stibnum second, and bismuth third. Reagent hydrogen sulfide and hydrochloric acid precipitate as sulfides. Okay, sorry. Precipitate as the copper sulfide, metal second, group second sulfides. If H2S is only passed through the solution, the ionic product of the corresponding metal ions and sulfides ions not only exceed the solubility product of group third B, hence acidified with the hydrochloric acid, hydrogen sulfide is passed through the solution. Hydrochloric acid is strong electrolyte and produce large number of H plus ions. H2S is weak electrolyte which produce small number of H plus ions. Due to common ion effect, dissociation of hydrogen sulfide is suppressed. At this time, ionic product is just sufficient to exceed the solubility product of group second metals, but not group third B metals, so that metal ions of group second are precipitated as the sulfide, but metal ions of group third B are not precipitated even they are present in a solution. Precipitation of group third A metal ions ferrous third, aluminum third, and chromium third precipitate as hydroxide solubility product of group third A metal hydroxide. If only ammonium hydroxide is added to the solution, the ionic product of corresponding metal ion hydroxide not only exceeds group third A but also exceeds solubility products of group third B. In order to avoid the precipitation of group third B along with group third A, ammonium hydroxide is added in presence of ammonium chloride. Ammonium chloride is strong electrolyte and produce large number of ammonium ions in solution. However, ammonium hydroxide is weak electrolyte which produces less number of ammonium ions in solution. Ammonium hydroxide. Dissociation of ammonium hydroxide is suppressed very much due to common ion effect. In this condition, ionic product is just sufficient. However, ammonium hydroxide is weak electrolyte which produces less number of ammonium ions in solution. Dissociation of suppressed very much due to common ion effect. In this condition, ionic product is just sufficient to exceed the solubility product of group 3 metal ions. Precipitation of group third B metal ions, zinc plus 2, cobalt plus 2, nickel plus 2, and manganese plus 2, precipitate as sulfides, reagent, ammonium hydroxide, ammonium chloride, hydrogen sulfide. Hydrogen sulfide is dissociated and zinc sulfide in a space where zinc. Okay, metal ions are precipitated as zinc sulfide. That is the group third B metal sulfides. Ammonium hydroxide dissociate and water also dissociate as the H plus ion consumed by hydroxide ions. More H2S molecule dissociate to produce the sulfide ions. As the concentration of sulfide ion increases, the ionic products of sulfides group third B metal ions concentration increases. As a result, the ionic products of the sulfides of the metal ions of the group third B exceed their solubility product and hence sulfides are precipitated. Precipitation of group IV metal ions, metal calcium plus 2, sodium plus 2, barium plus 2, precipitates carbonates. Calcium plus 2 and ammonium carbonate, calcium carbonate. If only the ammonium carbonate is added to the solution, the ionic product of the ions may also exceed the solubility product of magnesium carbonate, may also precipitate along with the group IV metal ions. In order to avoid the precipitation of magnesium carbonate along with the group IV, ammonium chloride is added before addition of ammonium carbonate. Ammonium chloride dissociates as ammonium plus chloride, strong electrolyte, but ammonium carbonate is weak electrolyte. Degree of dissociation of ammonium carbonate suppressed very much in solution due to common ion effect of ammonium. At this condition, the ionic product of group 3B metal ion carbonates is just sufficient to exceed their solubility product. Since solubility product of magnesium carbonate is high, it is not exceeded by its ionic product, so that group IB metal ions are precipitate but not magnesium. Gravimetric analysis: in this method of analysis, the constituent to be determined is precipitate from solution by addition of fluid-table precipitation reagent. Steps in gravimetric analysis: preparation of solution, precipitation, filtration, washing, drying, ignition, heating a constant fluid. The following requirements should be met in order to that a gravimetric method be successful. The separation process should be sufficiently complete so that the quantity of analyte left unprecipitate is 0.1 milligram or less is determining a major constraint of a macro sample. The substance weight should have a definite composition and should be pure, otherwise erroneous result may be obtained. Volumetric analysis: quantitative analysis carried out by determining the volume of solution accurately, known concentration, which is required to react quantitatively with the measured volume of solution of substance to be determined. An analyte is the substance in example that is being investigated, or it is component, element, compound, or ion in a sample whose amount is determined by a chosen method. The quantity of an analyte in a sample can be expressed in terms of mass, volume, concentration, moles, or relative abundance. Example: amount of iron second is analyte. Let a general reaction to titrant, the number of titrant molecule, number of analyte molecule. The addition of titrant is continued until an amount of T chemically equivalent, that is equivalent point. Indicated it is a third chemical reagent which changes color with competition of reaction. Endpoint: the endpoint is titration when the indicator changes color, known as endpoint. Redox reaction: the titration in reaction by oxidation in reaction is called redox titration. Permanganate titration, dichromate titration, iodometric and iodometric titration, iodometry. Complex formation reaction: it involves formation of complex by the analyte species with a titrant, which is solution in approximate lesion. Precipitation reaction: it involves the formation of insoluble precipitate when the two solutions are brought together. Primary standard solution: requisite for the primary standard solution. Secondary standard solution. Thank you. Okay, it's all about Unit 8, Qualitative and Quantitative Analysis, BSc first year. Okay, thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now. Bye-bye. See you again.